full screen it. And also, you will never ever see your name or face or anything like that on my recordings. I only record the lecture, that's it. I got a really fancy setup so I can do stuff like that. Good? All right, so 3.4 deals with solving geometry applications. So what we're talking about are triangles, rectangles, and my favorite, the Pythagorean theorem. Okay? Now, in order for us to really do all this stuff, we gotta kind of know some stuff about like triangles and squares. So I'm gonna focus on a triangle first. Okay? So triangles, we have basically two types. Well, actually, there's a couple. First one, this is called a right triangle. And we call it a right triangle because the lower left-hand corner of this triangle creates a right angle. That's what that little square on the inside means. That's our right angle. Okay? Now, within a right triangle, there is one side of the triangle that is very important. Okay? And that's called the hypotenuse. It's right here. The hypotenuse is always opposite of the right angle, and it's always the longest side. Okay? Now, inside of a triangle, so I'm going to draw just a regular triangle now, nothing special. So inside of the triangle, we always have three angles. Angles are always labeled with capital letters. And the measurement of all the angles will always add up to 180 degrees. Okay? Any questions so far? The perimeter of a triangle, and we label the sides with lowercase letters. The perimeter is nothing more than just adding up the sides or the lengths of each side. Okay? And the area of a triangle the formula for that is nothing more than just 1/2 times the base multiplied by the height. So the height of the triangle is right here. And the base is well, it's the bottom. To be honest with you, you already knew how to calculate the area without ever hearing about it. If you look on the screen real quick, I just drew a rectangle. If I labeled this B and this H, then the area of a rectangle equals B times H, correct? But if you cut this in half, notice you just created a triangle, so it's just half of it. So that's how we derive the area formula for a triangle. You take a rectangle and you just cut it in half. Good? Any questions about that? All right. So let's go over just a simple example. If the measurement of angle A equals 30 and the measurement of angle C equals 55, what is the measurement of angle B? So that little M and then it looks like a less than symbol means the measurement of the angle. Okay? Now, if you think about this, the formulas that I gave you above, measurements of the angles, perimeter, even area. Actually, no, I'm going to go back. Measurement of the angles. No, I'm right. I don't know why I'm thinking too much is the problem. Measurement of the angles, perimeter, even area. They're all linear equations. So you already know how to solve linear equations. That is what I'm testing you on when is your test? Friday. So if you know those 6 steps, all this is easy. So remember, measurement of A plus measurement of B plus measurement of C has to equal 180 degrees. Well, if I know what measurement of A is, it's 30. I don't know what B is, but I know C is 55. Well, I have a linear equation where all I have to do is just solve for the measurement of B. So 30 plus 55 is going to be 85. Then I subtract 85 from both sides. So what's 180 minus 85?
95.
Say it again, I didn't hear you.
95.
Perfect, thank you. So the measurement of angle B is 95 degrees. What do we think? Is this like difficult?
No.
All right. Excuse me. So let's talk about a rectangle real quick. So there's the shape of a rectangle, and remember, a square is a special rectangle. In other words, the statement all squares are rectangles is true. However, the statement all rectangles are squares is false. Squares are just special rectangles. A square means all the sides are the same length. Now, perimeter. All you got to do is just add up the sides. Now, I know many of us have seen a perimeter labeled like this. Perimeter equals 2 times L plus 2 times W. And that's because with a rectangle, opposite sides are always given the same letters. So I have 2 W's and 2 L's. Area of a rectangle is just length. Let me write it. Length times width, because they can be labeled different letters. And then lastly, all the angles inside, they have to add up to what? What do you think the angles got to add up to?
180.
Not 180.
360.
There it is. Has to equal 360. Okay? So here's an example. So if the length of a rectangle is 4 and the width is 2, we'll say 4 meters and 2 meters. Find the perimeter and area with the appropriate units. So go ahead, do that one for me. It is raining at my house now.
I can hear it sprinkling outside my bedroom window.
Yeah, we needed it. All right. Anybody get an answer, or do you still need a couple more minutes?
I got an answer.
What'd you get, Brent? For what? Perimeter or area or both?
I got both.
What'd you get for the perimeter?
I got 12 meters.
Okay, and what'd you get for the area?
I got 8 meters.
Okay, I disagree with your area. Anybody else? Megan? Megan H. You're muted. You were literally unmuted and then you muted yourself.
8 meters squared.
Ah, I like that a lot better. I like that a lot better, Brendan. So let's go over this first. Perimeter means add up the sides, correct?
Yeah.
So I know the sides are going to be 4 meters long, 2 meters wide. So if I wanted to, I can label everything. So this is just going to be 4 meters plus 4 meters plus 2 meters plus 2 meters. So perimeter equals 4 plus 4 is 8 plus 2 is 10 plus 2 more is 12. Perimeter, 12 meters. Now, the area is length times width, or length times height. Basically, it's side times side. So we have 4 meters times 2 meters. So my area is going to equal 4 times 2 is 8. And then I don't care how you write it, but you better say square meters. Brendan, you just said 8 meters. All right? So that's why I didn't agree with your answer.
Then the square can rewrite the 2 and then like the 2 above the 8.
You mean like this?
Or no? Yeah.
Yes, absolutely.
Okay.
Okay. How are we doing so far, everyone? Good? All right. The fun stuff. Pythagorean theorem. Has anybody ever heard of the Pythagorean theorem before?
Yes.
Do you remember what it is?
A squared plus B squared equals C squared.
Yeah, a squared plus b squared equals c squared. Now that's great, but what is that in relation to?
Trying to figure out either a missing angle or a missing side.
Okay, now these are all lowercase letters, so it's not angles. They are sides. Sides of what though, Wesley?
A triangle.
What kind of triangle? Any kind of triangle?
I think so.
No. Only right triangles.
Okay.
So what the Pythagorean theorem states is that the sides of the triangles are right triangles specifically are related. Now the letter A and the letter B, we call them legs. The most important side is the hypotenuse, and that is side C. That's the most important side. Okay? Now remember, the hypotenuse is always opposite of the right angle. Now Pythagoras was a Greek mathematician, philosopher, thinker of the day, grew up around 500 BC, and he came up with this a squared plus b squared equals c squared idea. All right? And one of the ways that he kind of demonstrated that, yes, this actually works is by using pictures. So I'm going to show you a way that he kind of demonstrated that this equation relates the right triangle's legs to the hypotenuse. And it's really easy. So what he did is he said, I'm going to go ahead and I'm going to take some squares. But more importantly, I'm going to draw these squares in a very specific manner. All right. Now, if I were to count the number of squares that I have, like little squares, I have 9 in this square and then 16 in this square. So what's 9 plus 16? What's that equal? 25. So maybe I should have did this with graph paper. Because what you would have noticed if I were using graph paper is when I created this right triangle here, this distance right here, this hypotenuse, would go through exactly 5 squares. So I need to draw a square with 5 or 5 by 5 squared. So in order for me to do that, I draw another square where it has the length 5 on all sides. How many squares do you think are in that square that I just drew right there? 25. So that's how Pythagoras kind of demonstrated to people that were not very math savvy of that day. This is how he demonstrated that yes, the sides or the legs of a right triangle are related or they're equal to the side of the hypotenuse. Now, when you come across a problem like this, we can break this down. Because we know what number to the second power is 9. 3 squared, right? And didn't I draw a 3 by 3 square? What about 16? What number squared is 16? 4. And what number squared is 25? All right, the crowd goes wild. 5 squared. So notice what I've done here is I just kind of demonstrated how this Pythagorean theorem works. Now there is something that we do need to know about. We need to know our squared table. So I'm going to write out some numbers because there is a relationship here. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. And I'm giving you the most popular. 11 squared is 121. 12 squared is 144. 13 squared is 169. Those are like the most popular. And the reason why I'm giving you this is because in order for us to solve the Pythagorean theorem, we got to know about these things called square roots. Anybody remember square roots? So, 1 squared is 1 because the square root of 1 equals 1. 2 to the second equals 4 because the square root of 4 equals 2. In other words, we're just forming the relationship here. So I can go all the way down this row or this column and just say, well, the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and so forth. You can go all the way down to the square root of 169 is 13. And the reason why I'm telling you that is this. If I just gave you a problem and I said, find the missing side, what you'd have to do here is you would use the Pythagorean theorem. You would notice, okay, I got a right triangle And I'm trying to find a hypotenuse. As soon as you see a right triangle, I'm going to be honest. You got to start thinking Pythagorean theorem. It comes up so much. So what you would do is you would use the Pythagorean theorem. You'd substitute in. You would say, well, 3 squared is 9. 4 squared is 16. So 9 plus 16 equals c squared. 9 plus 16 is 25. And then what you can do is you can go back to your table and say, okay, well, what number squared is 25? Well, that occurs right here, which means the square root of 25 is 5. Therefore, c has to equal 5. Does that make sense? I'm pretty sure we've all seen this before, right? Okay. So I will do this for you. Let me think about this here. I'm going to give you an example. I want you to do this example. Find the missing side. Actually, let me label this side 5. There we go. Find that missing side for me. Perfect. Anybody got an answer? Good. Good. I don't know who said what. What'd you get?
Oh, 144?
144?
Yes.
Okay, but that's not the final answer. You still need to simplify that.
That'd be 12 squared?
Not 12 squared, just
12.
Just 12, okay? So let's see how we go about doing this. Remember, the Pythagorean theorem is a squared plus b squared plus c squared. That c squared is the hypotenuse. That's the easiest one to find. So if you look on the triangle that I gave you, notice the opposite side of the right angle is the hypotenuse. That 5 is going to be the letter A then. So what we know so far is 5 squared plus b squared equals 13 squared. Now, we just got to go ahead, do our math, simplify it down a little bit. 5 squared is 25 plus b squared equals 169. Now, I need to solve for b squared. So I'm going to subtract 25 from both sides. B squared equals 9 minus 5 is 4. 6 minus 2 is 4. So B squared equals 144. And then if you just look on your chart, you'll see right here that 12 squared equals 144, which means B has to equal 12. Now, every single problem we've done so far has just been very nice because they've always been like whole numbers, like 3, 4, 5. This is a 5, 12, 13 triangle. Anytime you have answers that are just beautiful, nice whole numbers like this, does anybody know what that's called? Like a 3, 4, 5 triangle or a 5, 12, 13 triangle. There's a bunch. There's an infinite amount. They're called Pythagorean triples. And it's because they're just whole numbers. So I have something for you. So if you go to Blackboard, on the left-hand side, in the gray navigation panel, let me zoom in. It says extra credit. So you click on it. Here's your first extra credit assignment. You don't have to do it. I don't care. It's extra credit. But what I would like you to do is right there. It's one sentence. Prove the Pythagorean theorem without numbers. Now, it's going to require algebra. Okay? It's going to require some algebra. All you got to do is, I don't know, write it down or whatnot, scan it, and just attach the file right here. So if you need to know how to attach a file, I'll show you real quick. Let me just get rid of this right here. So let's see here. I have a file right here that says mom. Maybe that's my extra credit. I would just drag it and put it right there. Do you see how it turned purple? Let it go. Automatically uploaded. Once you're done, click submit at the end and you're good. Now this is due Friday, September 10th at 11 a.m. So it's right before our exam. Now it says point possible 1. But what I'm going to do is I'm going to, whatever question you miss, let me say it like this. The question that you miss the most points on, I will overwrite it with a correct answer. As long as you just do the extra credit. And the extra credit has to be right. Like you can't just, just put anything there. I mean, it got to be right. Okay? So that's what I would like you to do, is prove the Pythagorean theorem for extra credit. Are there any other questions? All right. Well, that's it. Let's review, shall we? I think that's pretty important. So, review for test. You should know how to identify linear equations. Okay? Step 2, or number 2. Well, if you know how to identify them, you better know how to solve them. How many steps are there to solve a linear equation? In general.
6.
6. Very good. Three. We went over linear inequalities. Graphing. And interval notation. Okay? Four. These are all the word problems, the applications. I will tell you exactly what's going to be on it. You will have one consecutive problem. That could be consecutive even, consecutive odd, or just consecutive integers. But you're going to only have one of them. You have 1% problem. So remember, we have, what's really nice is if you have that amount over the base equals the percent over 100. You have one mixture problem. And you're going to have one Pythagorean theorem problem. Okay? So now what I need to know is, do you have any specific questions about the topics?
Yeah, can I bail now?
You can totally bail now. All right?
It's a joke.
But I will be upset.
It's a joke.
I know.
Oh boy. I'm nervous.
Oh, don't be nervous. There's nothing to be nervous about. So, take a minute. Like I said, look it over. Do you have any questions?
Can we go over a quick mixture problem?
I would love to. So the ball game took in $1,376 on a Saturday. The number of $12 adult tickets Let me think about this here. Hold on, I'm doing some math in my head. The number of $12 adult tickets and $5 child tickets totaled to 138 tickets sold. How many of each type of ticket was there? Okay. So here's what's happening in this problem. There's a baseball game, and it took in $1,376. Now we know there were two different types of tickets. Adult tickets and child tickets. And we know how many tickets total we sold. What we're really asking for is, well, how many of each did we sell? So the best thing to do, start labeling things. Let A equal adult tickets. C equal child tickets. And here's what we know. A plus C has to equal 138. Like, we know that. Okay? But what we don't know is how many of each that we sold. But we do know their prices. The adult tickets were $12. And the child tickets were $5. Okay? So from here, I could create this equation here if I wanted. $12A plus 5C has to equal 1,376. Okay? Are we all on the same page so far? Now, there is a relationship here. And that relationship, and I'm going to highlight it for us, is right there. A plus C. If you knew that there were 38 adults that attended, then you automatically know there were 100 kids. Am I right?
Yeah.
Because if there were 38 adult tickets, you would take 138 minus 38 to give you 100 child tickets. And that's the relationship here. So when I'm looking at this, I consider and say, okay, well, why don't I just do this? Why don't I just say, and I'm going to write it in red, that the child tickets will equal 138 minus the adult tickets. And as soon as I know that, my equation down below changes. Because now I know what the letter C represents. The letter C is really 138 minus A. So I get 12A plus 5 times the quantity of 138 minus A equals 1,376. Does that make sense, everybody? Are we all on the same page there? Okay? So from here, it's just a matter of solving now. Linear equation. I don't see fractions, but I do see parentheses. So 5 times 138 gives me 690 minus 5A equals 1,700 or 1,376. 12A minus 5A is 7A. All right, now I'm going to isolate my variable term by subtracting my constant term. $1,376 minus 690 is 686. And then dividing both sides by 7. The number of adult tickets sold were 98 tickets. Okay? So I know how many adult tickets I sold. I can take this and go all the way back up there, and I can tell you how many child tickets. So children tickets. 138 minus 98 is 40. So I'm going to share this question because I think it's a good question. Why did I change A plus C equals 138 to C equals 138 minus A? Can anybody answer that question? The question is right here. At the very top, upper right-hand side of your screen, I have A plus C equals 138. Why did I turn that into C equals 138 minus A? Somebody explain that?
So that you can completely take C out of the 12A plus 5C equals 1376.
Okay, but that doesn't explain why I did it.
So that C was already on the side of its own.
Say that again.
So that C was already on a side of its own whenever you were ready to factor it in.
I know what you're saying. I don't like it though. I don't mean that in a bad way. It's just, I mean, there's something that we need to say.
So you only have one variable?
So first, Dylan's right. We only have one variable. That's great. But more importantly, I have no idea how many of either ticket I sold. All I know is the total amount was 138. So if I can isolate one of those variables, then I can find the other one. In other words, I know adult plus children has to equal 138. So I could have wrote C equals 138 minus A, or I could have did A equals 138 minus C, couldn't I? I mean, you're going to get the same end result. The only thing is, the reason why I changed it is, Dylan, I like the way you said it. I'm isolating one of the variables, but more importantly, those two things are related to each other. They're related by the combination of them. Okay? Are there any questions? All right.
I have a question.
Go for it.
So would it matter if you isolated A instead?
No. Would you like me to do it real fast?
No, I'm good.
Are you?
I just want to know if it matters.
No, it doesn't. Doesn't matter at all. Any other questions? All right. What about questions about what's expected of us? Review for the test. So if I gave you the test right now, everyone would ace it? Is that what you're telling me?
I'm not. How many questions, John?
That's a really good question. So I would say, I don't know how many questions yet, but I can guarantee you this. You know you got at least 4 questions right there, because you're going to have one of each of those problems. Okay? I would say 2 linear inequalities. That gives me up to what, 6 questions? And then maybe 4 to 6 of the just straight solving linear equations. So I would say anywhere between 10 and 12 questions is what I would go with.
Okay.
Okay? Is what I would go with. 10 to 12 questions. I think that will take about a half hour to 45 minutes for us to do.
Can you repeat that?
I said I think that'll take about 45 minutes, a half hour to 45 minutes.
For who?
Well, for somebody who really knows what they're doing.
Okay. There you
All
go.
right? But that's why I give you, what is it? 10? Or double time, is that right? Double time I said? For everybody?
Yeah.
All right. All right. So in WebAssign, if you went to WebAssign right now, okay, there are application problems for you. All right. So let me see if I can find them here for you. I hate doing this. Open student view. Here we go. Math SC05. Go. Applications for linear equations. All right. So it's not a big homework assignment at all. It's only 7 questions, I think, 7 or 8. Yeah, 8 questions. But it just deals with some mixing problems and then Pythagorean theorem, because I personally think the mixing problems and the Pythagorean theorem are the hard ones. Okay? So if there are no further questions, that's it for today.